doing question 610 that talks about a sleigh with two children, total mass 55.2, pulled along a horizontal snow-covered field by a rope that is at an angle of 35 above the horizontal. The coefficients of friction between the sleigh and the snow beneath it are static 0.15 and kinetic 0.095. What magnitude of rope tension is required to keep the sleigh moving at constant velocity? So, what I have here is the following. So this is Fg, this is Fn, this is the friction, Ffk, and this is the force F that is making a 35 degrees angle with the horizontal. So I have mass here as 55.2 kilograms. I have mu s as 0.15, mu k as 0.0995. So moving at constant velocity means that the forces are, there is no acceleration, so I don't have acceleration ax. I assume that this is my x, this is my y, then ax equals to 0, then I can use Newton's law, which is Fx here equals to 0, and sigma Fy are also 0. So let me start first with the sigma Fy equals to 0. What do I have along the y-axis? I have Fn, right? I have Fg, however, in the opposite direction. What else? I have the projection of F along the y, which is, let me call this one Fy. So this is positive plus Fy equals to 0. This means I have Fn that equals to Fg minus Fy, and then Fn equals to n e minus f. That's what I have here. Sine 35 degrees. Right? From sigma x, sigma fx equals to 0, what do I have? I have f cosine 35 degrees minus ffk equals to 0. Then ffk, and reflection, Okay, equals to F then sine 35 degrees. Also, what do I know? I know that f of k equals to mu k times f n. So if I put this one and this one too, then and this one is 3, then substituting 1 and 3 gives me f of k equals to mu k times mg minus f times 35 degrees, right? Now, if I call this one 4, and then equate 2 to 4, what do I get? I get f cosine 35 degrees equals to mu k and g minus f times 35 degrees, right? Now, if I substitute cosine uk and g sine 35, I end up with one equation, one unknown. Right? So I have here f times 0.82 equals to mu k to 0.095 times m, mass is 55.2 times 9.8 times f times sine 35, which is 0.57. So I have 0.82 f equals to 51.4 minus 0.054 f. Take f this side, then f equals to 58.8 in Newton. That will maintain a constant velocity and at the same time overcome the kinetic friction. Now let's move to the next question. Next question from study guide 4, self-test 1, question 2. Okay, so Kramer decided to hit golf balls from the edge of a cliff into the ocean. The cliff is 62.9 meter height. He hits the first ball, mass 45.9 gram, giving it an initial velocity of 37.5 meter per second at an angle of 22.1 degrees above the horizontal. A. Determine the work done on the ball by gravity on the way up to its maximum height. B. Determine the work done on the ball by gravity on the way down to the ocean from its maximum height. So let's start first by drawing. I have this graph here. Height is 62.9 meters. I have my coordinates being x and y this way. This is the ball here, the golf ball. We have this velocity. It's going to go all the way up the maximum height here. Right here, the velocity will be 0, right? The velocity here becomes 0. So we need to calculate the work done on the ball by gravity on the way up to its maximum height. So the first thing we need to do is to define this height. So if I want to, let me call this one as V X. No, this is C. Now this V will be decomposed. Again, the angle here as 22.1. So I have 22.1 degrees. Now this velocity will have two components. We'll have the Vx and we'll have the Vy, right? So I know Vy is V sine 22.1. So let me just say that V here is 37.5 meters per second. Theta is 22.1 degrees. And I have the mass of the ball as 45.9 grams, which means the mass is 0.045 kilograms. I know Vy as V sine 22.1 degrees, right? So if you remember the motion equation for such a motion here as Vy squared minus V y naught squared equal to 2 ay y minus 1. So I am after this. This is my delta. I need my delta. This is the delta y. This is my delta y. I know the acceleration. Ay here. My ay is minus 9.8 meter per second squared. I need delta y. The final velocity would be 0, and I have the initial velocity, which is v sine 21.1. So I have here minus 22.11 squared equals to 2 minus 9.8 times delta y, and delta y equals to 10.15. This is my delta y. It's going to give me the maximum height. Now I have delta y, which basically this is the magnitude of my displacement, and this displacement is pointing in the positive y direction. Now the gravitational force of this ball is pointing downward. So if I am to look at this again, reflect from here, the ball was here, then this is the maximum, right? So the displacement was in this direction. You can look at this in delta r, the vector is in the y direction here. So this is y. And I have the gravitational force, Fg, pointing downward, right? So now if I want to write the work would be F times delta r magnitude, original magnitude, cosine theta. So in this case, if my displacement delta r pointing up and my force is pointing downward, then theta is 180 degrees, and cosine theta here becomes -1. Then if I continue, the work is F is Fg, my delta R here is delta Y times -1, and the W becomes minus mg delta Y, and the work is minus 4.572. So this is the work done by the gravity on the ball. B, determine the work done on the ball by gravity on the way down to the ocean from its maximum height. Now remember here the displacement was pointing upward. However, the gravitational force was pointing downward. That's why the angle between those two vectors was 180 degrees, and this gave me a cosine of -1, equals to -1, and that's why the work is negative. However, now let's look at the second case. W2 again is F times delta R times cosine theta. In the second case, I have the ball here right at the maximum. So now my total here become, this is 10.15 meters. This one is 62.9 meters. Now look what's going to happen. The ball is going to fall from the maximum height towards the ocean. In this case, the displacement vector will be pointing downward, and the gravitational force is also pointing downward. So theta in this case becomes 0. So now if I am to write the work done by the gravity on this ball from the maximum height all the way to the ocean, W2 becomes, F is again Fg. My delta R here is 10.15 plus 62.9, and my cosine theta becomes 1. Then W2 is again the mass, 45.9 to the power minus 3 times 9.8 mg times 70 73.05, and the work is 32.86. Any questions so far? No questions? Okay, so let's move on to the next question. Next question is from Study Guide 4, Self-Test 4, Question 1. Okay, so I will draw the figure first. So I have a box at point A. A box is sliding at 11.2 meters per second. At point B, the box's speed is now 7.11. So the velocity here, if I am to call this one point A, point B, 7.11 meters per second. the box has a mass of, so this is study guide for self-test 4, question 1. Okay. So here we have the mass as 12.5 kilograms. EA as 0.2 meters per second. VE as 7.0 meters per second. Determine the amount of thermal energy produced while the box is sliding up the slope. Okay, so the energy, oh sorry, the thermal energy here will be produced due to the friction between the box and the slide. So it is very important to know that when we say thermal, it will be producing thermal, so the energy here will be positive energy. However, the friction here will give me a negative energy. So we can look at it as the thermal is the opposite of the friction. In this case, I will write the equation such that the work, the total work due to the friction, due to the kinetic friction, will be the difference between the energy at point B and point A. So if I am to call this here as my, let's say this is B, point B, and this is the point A. So I will be looking at the difference between both energies. So let me call this one EK2 or EKB plus EPB minus EKA plus EPA. So for EKB, I have half mv squared plus mgy 2 minus half mva squared plus mgy1. So here what do we have? We have the final as half times the mass 0.5 times the 7.11 squared plus 12.5 times 9.8 times the height equals 12 minus. For A, I have a kinetic energy here, half times 12.5 times 7.2. So, however, the potential energy is zero because we are at the reference. So if I take this x and y, so this is my reference. This is y equals to zero. In this case, you work out this equation. What are you gonna get? You're gonna get 315.95 plus 382.2 minus 784. Then okay equals 3 minus 85 85 is we have W thermal equals to minus K equals to 85 so 85. This is part A. Part B is determine the distance between point A and B. The force of a friction on the box while sliding up the slope is constant 18 point. So we have FFK is 18.3 Newton. We go back now to the expression for the work. We need to find the distance. We can find the distance from W equals to F delta R, which are the magnitudes of those two forces of the displacement and the force, times cosine theta. Now, if you know that WFFK is minus 85.85, and you know the force is 18.3, right? The force friction is 18.3, yeah, 18.3. We need delta R, and we know that theta in this case is 180 degrees. And this is minus 1. Then delta R is 85.85 divided by 18.3. Delta R equals to 4.69. Okay, so this is the end of question number 1, self-test 4. Let me move to the, I have 2 more questions here. I think, let me do 113. 113 is interesting from the textbook. So we have 7.113, and it reads the following. Two men hang onto opposite ends of a rope that passes over a pulley. The masses are M1 105 kilograms and M2 67 kilograms. Initially, the men at rest, with man number 2 standing on the floor and man number 1 supported with his feet 1.5 meter above the floor. The support is then removed and the man and rope are free to move. Use conservation of energy to determine the speed of the man, just as man number 1 touches the floor. So here we have man number 1 as M1, 1.5 meter far, and this is the rope. Passes over the pulley, and this man number 2 is right here. Now this is my coordinates. Positive y is up. So this is my y equals to 0 reference. V1 initial is at rest. So here is, we call this one V1 initial is 0. Also V2 initial is also 0 because they're starting from rest. And then as you can see here, M1 is 105 kilograms, M2 as 67 kilograms. Now the interesting thing about this problem, as you will see, so I have FG1, FG2, sorry, and I have FG1. That when you do the conservation of energy, for those two masses that are connected together with this rope, you have to do it for both of them. What does this mean? This means that when you write the conservation of energy, the energy before equals the energy after, you have to go, so this is my initial, and this point is my final destination. Same thing here. This is going to be, when this one goes up, it's going to be the final destination. So you go as EK1 for this one, initial, plus EP1 initial, plus EK2 for here, initial plus EP2 initial equals to EK1 final plus EP1 final plus EK2 final plus EP2 final. So you do all of them together at the same time, while paying attention that the initial kinetic energy for both of them, because they were at rest, will be zero. So I have here velocity 0, then EK1 initial is 0. I have this guy also, EK2 initial as being 0. What else? This one is the start. This one, when he was here, the initial, he was at the reference. So the EP2 initial is 0, right? So 0 kinetic energy here, 0 kinetic energy here, and 0 potential energy here. So I ended up only with the potential energy for mass number 1, initial. This equals to what? EK1 final. So now we have to write the kinetic energy right at this point. And also I have to write the potential energy here will be 0 for 1. So EK1 final, sorry, no, the potential energy here will become 0. EP1 final, because now he will be at y equals to 0. Then this one, EP for 1 final is 0. So also one thing to pay attention to, that the velocity will be the same for both of them, right? So the velocity here at this point will be F or V2F, and here V1F, they're the same. So I have here V1F equals to V2F as well. So now if I'm to substitute, I have mg initial, which is y 1.5 meter, the rest are 0, equals to EK1 final right at this point, which is half m1 vf squared. I'm done with this. Now let's move to the EK2 final. EK2 final here is half m2 vf squared. Now plus EP2 final. EP2 final is m2 g y. The same y, 1.5. When this one goes 1.5, this one goes up 1.5. So here, this is m1, right? So if you take m2 to the other side, what do you get? I get m1 minus m2 G Y equals to take half df squared outside, so df squared over 2 m1 plus m2. Now if you substitute m1 minus m2, 105 minus 67 times 9.8 times 1.5 equals to df squared 105